And last night I was sitting in the back and I couldn't see half of the screen because of all that I had.
She misbehaves, just let me know. She's my child. I'll chat with somebody across here.
Alrighty, guys, everybody find your seats. Make sure that you guys have got a drink. If you guys have not tried one of Duco's famous G&Ts, then you are missing out. All right, so how many people have G&Ts tonight? Raise them up. Awesome, guys. We got quite a few. Well, if you don't have one, definitely get those back at the bar. That is Shea Booba's bar. We're in Long Hall tonight, but they are the ones sponsoring it, is Shea Booba. So we'll get started in just a minute here once everybody's settled. Doing tonight? Welcome, everybody. Woo. We are back here for another awesome See and Learn presentation. Real quick, we do want to thank a few sponsors that help make all of this possible. The very first is Carib Trans. They are doing sponsoring all the live streaming. We also have Solera Dunia, who is hosting our speaker for the evening. So big welcome to them. And, of course, big round of applause. And then none of this would be possible without the Prince Bernhard Culture Funds Foundation and public entity SEBA. They help us out with a lot. So big round of applause right there. And to all of our other sponsors. It takes a lot to make See and Learn happen. So we've got a lot of people that are helping us out here tonight. So huge round of applause to all those people that are out there. And again, the bar tonight is sponsored by Shea Booba, so definitely bar and dinner afterwards. I know we're in Long Hall right now, but it is going to be up at Shea Booba if you've already made reservations, all right? Now, we do have some awesome raffle prizes, and I think Lynn or Emily has the raffle box right now, and they're selling some tickets. They're just $5 each. You can win a lot of different things. There's an indigo cover-up, some handmade jewelry, a lot of different cottages and villas are giving away 3-night stays, so crazy value out there. Signed copy of Edie Witter's new book, some nice baskets that are full of homemade like perfumes and moisturizers and things like that. 8-day, 7-night, fully paid for live aboard, all diving and meals included, so that is awesome. A guided hike from SCF, and even a homemade knife from John. So definitely some cool prizes that are out there. If you guys want to help support See and Learn, buying raffle prizes or raffle tickets is always a great way. Or if you're looking to help us out even a little bit more, maybe you could get your own logo up there on the slide before and give us a bigger donation. That does help us out a ton, and it's what really lets See and Learn keep going every single year. It takes a lot of people to make this happen. So awesome. Now, we're going to do a quick recap of some of the stuff that's been going on the past few days, if you guys haven't been able to make it out. So up in the upper left, we do have Elska and Reinaud's volcano monitoring field project that they went on. So we brought quite a lot of people out there. We had an ROV building session with Erica Moulton, so that was awesome. Kids had a ton of fun. We had some adults that acted like kids, and then we had some actual kids that were there having a great time. We had a night hike with Lauren Esposito and her crew. So you can see Emily over there braving the wolf spider, I think it's called. Whip spider, that's what, thank you, he knows. The whip spider right down there in the corner, and then just some pretty cool stuff. That's the glowing scorpions. We also, just the other day, had a scuba diving adventure with Tadzio looking for sharks. So I think they found a turtle, a nurse shark it sounded like, and then his presentation was right here at Long Haul just the other night. So had a really great turnout. Looks like we got a really awesome turnout tonight too. So that's just what we've been up to. Real quick. We do have a few things that are coming up. So October 13th and 14th, that's Wednesday and Thursday at 1 p.m., we have a turtle and shark dive with the speaker tonight, Mitch Rider. So definitely check those out. On the 13th, we also have our next presentation at Hell's Gate Community Center, Solar-Powered Sea Slugs with Michael Middlebrooks, and the school will be sponsoring some of the food that night, so it's a great way to come out and support the schools that are out here. And we have another day of diving on the 14th, actually looking for those solar-powered sea slugs with Michael. So definitely come out for all those events. But for tonight, we do have Mitch Rider. Now, does any... Woo! Man, I haven't even told you guys anything about him, and you're already excited for him. Jeez. Legends. You heard it here first. All right, so I have a question for you guys. Does anybody have a memory of something that happened that's funny now, but when it happened, it probably was pretty serious or not very funny? Well, just from talking with Mitch for a little bit, he's got a lot of those, all right? Now, you'll have to ask him about those of a beer later tonight, because for right now, he's going to talk to us about the more professional side of his career. Now, he does work with Acoustics, but that does not mean he's a good singer, so please do not ask him to sing, all right? Freebird, right? So Mitch got his master's at the University of Miami, studying the interactions of boat traffic and shark movement, and is working on his PhD studying leatherback sea turtles in the northwestern Atlantic Ocean. He has worked with NOAA, the National Oceanic and Atmospheric Administration, studying the bluefin tuna catch. Yeah, we got some NOAA representatives in the house. That's awesome. He manages the Acoustic telemetry network in Biscayne Bay and is involved in several shark tracking projects despite him working on turtles right now. He's still involved with some of his master's work. And now, without further ado, let me introduce you to the telemetry celebrity himself, Mitch Rider.
Wow. Thank you for that introduction. How's everybody doing? That's wonderful. I really want to thank See and Learn Saba for having me out here. JJ, Emily, Lynn, Adam doing the technical support, John taking the photos, and the whole island of Saba making me feel extremely welcomed here. I really appreciate it, and I really appreciate you all coming here to listen to me talk. As you can imagine, the last year and a half I've spent hunkered down behind my computer working on all these different projects. So one, this is the first time I'm talking in front of any person for the first time in 2 to 3 years. So bear with me on that. I might have a little nerves. And I'm also really excited because, to talk about this research, because I've literally been looking at my computer screen at it for 2 years now. And now this is like the first time I've been able to present on it. So I'm very excited to do that in front of you all. So today, just a little preface of what I'm going to talk about. I'm going to go over one specific project that paper that we came out with earlier this year, which is going to be the multi-year movements of sharks in the Northwest Atlantic as assessed through acoustic telemetry. And then afterwards, I'm going to highlight a couple other research projects that we've just had published as well, such as how do sharks and boats interact? I believe somebody was asking, but I believe you were asking that very question last night. And I heard your question, and I added it to my presentation so I could answer your question. And then also wondering if you've ever wondered what sharks do during hurricanes. It's not like Sharknado, but it's Sharkicane, or however you want to say it. But we'll go over that as well. So I know Tadzio kind of highlighted this yesterday, but highly migratory species, these are going to be species that are defined that they move across multiple exclusive economic zones, and they also go out in the high seas. And a lot of these are going to be commercially and ecologically important species, such as bluefin tunas, leatherback sea turtles, which I'm doing for my master's. If you were here for turtles tonight, I really apologize. I just didn't have the time to analyze the data before this, so you're going to have to deal with sharks. And also whales as well. And it's really important that we monitor where these species are going, what their spatial patterns are, what their movement patterns are, because as we know, climate change is becoming a very big issue. So when it comes to climate change, we want to analyze how is that affecting where these species are going. Are they pushing species into new environments and causing them to interact with other species, which can cause a whole catastrophic amount of bad things to happen? So these highly migratory species, they can be especially in the marine environment, they can be very hard to track. It's not like tracking deer in Colorado where you can actually see where they're going. These are sharks, these are turtles. Turtles are easier because they actually come to the surface, we know where they nest, but sharks especially, it's extremely hard to figure out where they're doing these things, where are they mating, where are they giving birth, where are they traveling to. And so that's where, humidity. And that's where acoustic telemetry and satellite telemetry and different types of tracking come in. In the past couple of decades, there have been huge technological advancements in tracking devices. Tags will last a whole lot longer. It used to be that satellite tags would only last a couple of weeks to a couple of months. Now they can last a couple of years. We have acoustic tags that can last up to 10 years now, which is incredible. We can also store a lot more data during that time. They can take different temperature readings, they can take salinity measurements, they can take depth, they can also do accelerometry, which is basically showing how fast does a shark move at certain points, where we can assess, okay, if we look at how fast a shark is swimming, it might be feeding there, it might be actively pursuing prey here, it might be migrating there. And some other cool things is right now they have predation tags. And I love talking about this tag. I think it's the coolest thing in the world. Imagine you tag a prey fish, just a small fish species with a tag. It pings, you know where that fish is going. Suddenly, you get a new tag number. What happens is when that fish is eaten, the stomach acids within the predator will change this little polymer that's on the tag, and it will change that number. So you can see when a predation event happens. It's incredible. It's like the coolest thing, right? I don't work with those, I wish I did. But it's an example of how these different types of technological advances can really help us get a better picture of what's going on in the marine realm. So today, my main study species that I'm going to be talking about is going to be the bull shark, or Coccurhinus lucus. And they are going to be found throughout the world. There's studies on bull sharks in Australia, in the Indian Ocean, all across South America, North America. These sharks are everywhere. However, they are just recently listed as near threatened by the IUCN. So it's very important that we make sure we know where these sharks are going, what they're doing, so that we can prevent them from going to that next level of being endangered or critically endangered, like we see with great hammerheads or tiger sharks or anything like that, or like great whites as well. So if you don't know already, bull sharks are extremely cool because they can swim in both salt water and fresh water. There are stories where bull sharks will travel up the Mississippi River all the way up to Illinois or Indiana, and that's just nuts to think about, that a shark can be all the way up there. And they also, they've been characterized, their migratory patterns have been characterized across the world. Like I was saying, in Australia, they tracked them up and down the Australian coast. They've tracked them up and down the South African coast. They've also tracked them in the United States. However, they use some different telemetry technology as well, I'll get into in a second. So with this study, what do we want to know? We want to know where these sharks are going, basically. We're tagging these sharks just off the coast of Miami. So like JJ was saying, I'm a student of the University of Miami, so we have a lot of bull sharks that are tagged off there. So we want to know bull sharks that are in Biscayne Bay off the shore of Miami, where are they migrating to? Is it different from bull sharks that are up the coast of Florida or in the mid-Atlantic that are being tagged there, or in the Gulf of Mexico? We are also wondering is what is driving these movements? Is it prey species? Is it temperature? Is it chlorophyll? Is it salinity? And also we want to know about the connectivity patterns. Are they going to one place and are they coming back? Do they leave Biscayne Bay, go to the other side of the Florida Peninsula, and come back, and so on and so forth? So Tadzio highlighted this a little bit yesterday if you were here for it, but when we actually do our shark capturing and tagging, we use a drumline system. So the way that that works is we have a drum, which is about, I want to say 40 pounds. And attached to that drum, we have a line that goes to the surface, and we have 2 marker buoys. And then off of that drum, we have a line. And attached to that line, we have a hook timer. And the cool thing about a hook timer is if a shark actually bites a line and we catch it, it'll pop that hook timer and allow us to see how long that shark's been on the line. And that's been huge for certain studies that we've been looking at, is how sharks get stressed on the line. So when we actually take these sharks in, we'll get blood samples and we'll analyze things like plasma content, hematocrit, and we'll be able to see how stressed are sharks the longer that they are on the line. And some cool things that actually came from that study is we found that great hammerheads were extremely stressed. I know we were talking about that last night. It's very true. So we found that the longer they were on the line, the higher their stress levels were. And that actually led to some Florida legislation that made it so that if you have a hammerhead on the line for more than an hour, you have to cut the line. So the way that we do this is we usually set out 10 drums per set, and we usually do about 4 sets per day. And when we actually catch these sharks, we actually use a jet ski platform to sort of hoist them in, and they're nicely tucked in this little part where the jet ski would go. And you can see us pulling up a nurse shark there. I know Tadzio yesterday was saying that he did not like to work with nurse sharks. I can affirm that they're just really hard to work with. They just are like big wet noodles, very strong too, and they throw you around, and it's not the most fun thing in the world. But once we pull them on, we'll secure them, and usually depending on the species, especially like this bull shark here, we will put a water pump into its mouth so that we can ensure that it keeps getting water over its gills. And then once we do that, we start to do our science work. We start to take measurements. We'll take blood samples. We'll take fin clips, which are going to be great for using for in genetic analyses. And one of the cool things that we do at the University of Miami is we have a citizen science program. So what that means is we take out school groups, we take out sometimes corporate groups, we take out anybody to come shark tagging with us. So if you're ever in Miami and you want to go shark tagging, you just got to look up sharktagging.com. I don't know how easier that it can get. But we'll take you out, and you can actually do measurements on these sharks. You can tag the sharks, and you can also take the fin clips as well. And each one of those, the people who come out with us and help us out, it's a huge help. It's unreal how much the citizen scientists help with this project. So once we have everything done, we'll release the sharks and we'll push them back in the water, and it'll look something like this. There's a nurse shark there. And then here's a tiger shark that we worked alongside the boat. We sometimes do that as well with a satellite tag attached to it. So before I go into acoustic telemetry, like I said before, with bull sharks, there have been studies in the United States that use satellite telemetry. And those were great studies to show different parts of the United States that these sharks were going. But the problem with bull sharks in using satellite telemetry is they're more of a benthic species. The way that satellite telemetry works is that they'll come to the when something comes to the surface, it'll send a signal to a satellite, right? So it needs to be at the surface long enough for this sensor to dry off So it can send a signal to a satellite, and a satellite sends a message back to our computer, and somebody in my lab manages those data, and they'll log on every morning, and they can see where all our sharks are. However, with bull sharks, that's not very easy when they don't come to the surface as often. So that's where acoustic telemetry comes into play. And the way that acoustic telemetry works is that you have this tag that we insert, and it can either be surgically inserted into the body cavity, or we'll attach it to the fin. And the way that it works is it emits a frequency, like a high frequency ping, and it will ping 8 to 10 times in a certain pattern. And that certain pattern, whenever they come within one of these receivers right here that's listening for it, whenever they hear that full pattern, it'll be able to say, oh, shark 1, 2, 3, 4 was here today at 2 p.m. So this is more of a passive way of tracking these species, but it's great for species that don't come to the surface. Because the other thing with satellite tags is they can be about $5,000 a piece. And when you want to have a sample size of 30 sharks, well, that's a pretty hefty bill. The great thing with acoustic telemetry is those tags really only cost $300 to $500 a piece. And the receivers themselves cost about $1,000. So it's a little more bang for your buck if you want to go that route. But anyway, as these sharks are going, they'll swim by, and the receiver will pick up that transmission. And I go about every 6 months, I go to our acoustic array that we have here in Miami. So this is Biscayne Bay. For reference, Miami's up here. This is Key Biscayne, if you all are familiar with the area. And each one of these red dots is an acoustic receiver station. So every 6 months, I go out and I download these data, and I just get a whole list, and it'll just tell me the tag number, it'll tell me when it was there, and that's pretty much it. So then I got to go back to my lab, and I got to pair that with metadata that says this tag number is this shark, and this tag number is that shark. But this is a great way to track these types of species. That's the acoustic tag right there. They can vary in size. This is the one that we use, and it's just like a battery. It's very small. That's internal, yeah. Externals are going to be about the same size. And what we'll do is when we bring these sharks on board, most of the time when we're doing these surgeries, we'll do these in water, and we'll flip them upside down, and they'll go into tonic immobility, sort of like a tonic state where they stay really still, and it's really easy to work on them. And we'll do a quick surgery, and you can kind of see the suture right there, and we'll quickly implant it, suture it up, and it's really crazy how quickly these sharks heal. I was looking on Twitter the other day, and I have a colleague who works up in Nova Scotia, and they were tagging blue sharks the same way. And somebody went out, tagged a blue shark. 2 weeks later, they caught the exact same blue shark. It was completely healed. It was if there was no surgery at all. There was just the sutures left. You could not see a line. It was just absolutely crazy.
How long does the sensors last?
About 5 to 10 years. Yeah, depending on the size. If you do smaller fish, you're going to have smaller tag sizes, and they'll last shorter. Yeah, the battery's not large enough. What's that?
Isn't this just another reason to study sharks because they heal so quickly?
Sorry.
Isn't it just another reason to study sharks because they heal so quickly anyway?
Yeah, exactly. Yeah. She was asking if it's another reason to study sharks because they heal so quickly and we can do this kind of work, and it's a lot more ethical. So you might be wondering, all right, Mitch, you have this array in Biscayne Bay, and you want to do a migratory study on bull sharks. How are you going to do that? Well, they're going to go from one side of the bay to the other. Well, no, that's not going to be a great paper, right? Well, we have these things, and I think these are pretty incredible. These are cooperative acoustic telemetry networks, and there's a whole bunch of them, and I'll go over them each. These are basically, we're not the only ones to be using this type of technology. A lot of different researchers are using acoustic arrays. And one of the cool things is if my shark travels from Biscayne Bay and goes onto one of these other receivers, if that researcher is a part of this cooperative tagging network, they will send me those data, which is a great thing. So one example here is the FACT network. And the FACT network stands for Florida Acoustic Cooperative Telemetry. FACT. Fish move, that's a fact. That's their motto. I actually just got that a couple days ago, unfortunately. And so you can see here that the Florida Acoustic Tracking Network, they pretty much go from the Gulf side and they'll go all the way up towards Virginia. So they have a pretty good spread, so it's not just in Florida. Another one is going to be ITAG, or the Integrated Tracking of Aquatic Animals in the Gulf of Mexico. And these arrays are going, each dot is going to be a specific array, so it's going to be multiple receivers within each point. And these are going to span from Texas all the way over around into Bimini, the Bahamas. And also, this is the biggest one, is going to be the Ocean Tracking Network. I just took a screenshot of their receivers. Each number is the amount of arrays, not just the number of receivers, the amount of arrays in the area. They have them all across the globe. So if by chance I have a shark that goes all the way to South Africa, it will get detected and I'll get those data. That would be something else, but that is absolutely possible with the acoustic, with these tracking networks, especially the Ocean Tracking Network. So it also goes vice versa. If I detect something on my array, I can send those data out. And in Biscayne Bay alone, we detect a lot of different things. So you already saw that. We'll detect a lot of different turtles. We'll detect green turtles, loggerheads, hawksbills, Kemp's Ridley. It's pretty incredible. And they're all coming up from like South Carolina. So they're moving a long ways down, getting detected on our array, and I'm fortunate enough to send them those data. And also different types of sharks. Bimini's lab, or shark lab, we get a lot of their sharks that come down. We have a lot of black tips that come down from South Carolina DNR. They tag those sharks, we detect those. We also detect permit and tarpon and bonefish. If you guys are familiar with the bonefish tarpon trust, we detect a lot of their fish in our array as well. And actually, some other cool ones that we detect are spotted eagle rays. And also, then this one's my favorite, is the small-tooth sawfish. Very recently, within the past couple of years, we started having all these different, occurrences of small-tooth sawfish, which are an extremely endangered species. And then out of nowhere, we started detecting them on our array. We caught a couple on our Drumline sets. We started getting them on our baited remote underwater videos. So having this array is really not just beneficial to our lab and the sharks that we tag, but is extremely beneficial to other researchers that want to know what these fish are doing in our region or beyond their own region as well. So going into exactly what we did, we tagged a total of 22 bull sharks, 4 males and 18 females. And of those 22 bull sharks, we detected 16 for more than 10 days. And I'll get into why that's important in a second. And of those 16, we detected 2 males and 14 females. And their detection spanned from Louisiana to Maryland, which is pretty incredible if you ask me. I did not realize this when I was starting this project. This project was separate from my master's. I just happened to be managing these data, and I looked at where all these bull sharks were going, and one day I popped up this and I made this graphic, and I was like, we gotta look into this further. So my advisor and I sort of hunkered down, did these analyses. Another PhD student, Laura, really helped me out with a lot of the work as well, which I'll highlight in a second. But what we did from here is we took these receivers and we made these different groupings based on the regions that they were in, that go from the North Gulf all the way to the Florida Gulf Coast here, Florida Keys, Florida Atlantic Coast, Florida to North Carolina, and then the Chesapeake Bay and the Maryland coast. So after we got those data, we wanted to compare their residencies across these different regions. We wanted to see where are they spending the most time, what time of year are they going there. So first we had to do these things. We had to filter with false detections. Now acoustic telemetry, like I mentioned, is a lot cheaper than satellite telemetry, but it's a little bit harder because they're listening. They're listening for sounds. And there's a lot of there's a lot of noise pollution going on. So a lot of the time we get a lot of false detections. So, and sometimes you'll get a lot of pinging coming from boats, coming from pile drivings. And what we have to do, and when that happens actually, we'll actually get a tag, like one of our tags will say that it's detected. And I've gotten sharks that were detected in the Great Lakes, but obviously that's not what's going on. So we have to filter for these false detections. So it's essentially removing these false positives. So we also had, like I was saying earlier, we had to use sharks that were detected for longer than 10 days. And that's just to increase our sample size of detections per shark, and also so we can establish some patterns of where these sharks are going. So from those things, we computed these things called monthly regional residency indices. And a residency index is a way for us to compare one shark to another, because we tag sharks at different times. So having a shark that's only been detected or being out there with a tag for a month is going to be a lot different from a shark that's being out there for a year. So we want to sort of go in between those different sharks. We want to actually be able to compare those. So we do these things called residency indices. And for this case, we did these monthly regional residencies. So per month, per region, we just took the days detected and divided it by the days at liberty, or how long the shark was actually out there, and then multiplied it by 100. So how long did they stay in these different regions? You can see here these are going to be the different regions that these sharks were detected in, and you can see that these are going to be those average monthly residencies. So if I can orient you here to Biscayne Bay, you can see that these numbers, it's a little hard to see here, but these numbers that they're being detected are way greater than any of these other regions, meaning that they're spending a long time in Biscayne Bay compared to these other regions, which is insane because, you can just, if you just happen to tag this shark in Biscayne Bay, it doesn't necessarily mean that it stays in Biscayne Bay. It can go anywhere. But the fact that we're detecting these sharks in Biscayne Bay for a lot longer than these other regions is very important. I'll get into that in a second. But you can see it's a little bit similar in the Florida Keys, mostly because it's very connected to Biscayne Bay. But in Biscayne Bay, you'll also see that there's sort of this dip. I don't know if Saba has a wet season and a dry season. Do you guys go by wet season, dry season here? Sort of like the wet seasons, like hurricane season, and then dry seasons, everything else. Well, you can see that these bull sharks are leaving in the wet season, and then they're coming back in the dry season. But as you can see that dip, you can go north to these other areas, and you can see these spikes during the wet season, especially up in the Chesapeake. You can see it in the North Florida Gulf. You can see it in the Florida Gulf Coast and the Northern Gulf.
Where is that temperature?
What's that?
Where is that water?
I'll get into that in a sec. Yeah. But you have these seasonal movements, and you can look and see if they're just transiting areas versus residential areas as well. So like I was saying earlier, Biscayne Bay is going to be more of a residential area because they're spending a lot of time there. Florida Keys, on the other hand, these residencies aren't that high compared to Biscayne Bay, so this is going to be more of a transiting area for these sharks. So if we zoom in on Biscayne Bay even closer, like I was saying before, you can see that their residencies, the time that they're spending here, is going to be a lot greater in these early months and later months. But you'll see this big dip between June and October. And if you look at the temperatures, which is going to be this line right here, you can see that that definitely correlates with the temperature. So one thing that we're finding is that these shark movements are temperature driven. So what is driving these movements? A lot of it's going to be temperature. Here are the different regions that we looked at and that we had enough data to do analyses on. And you find that in the northern Florida, from North Florida, South Carolina, and the Florida Atlantic coast and Biscayne Bay, you have these negative trends with rising temperatures. So the residency is decreasing in these areas when the temperature is rising. So it's definitely temperature driven. And as you go in the Florida Keys, that one was actually insignificant because it's a transit area. They're just passing through. Doesn't really matter what temperature it is. And one of the interesting things is in the Florida Gulf Coast, it's actually the inverse. They're going over these areas while the temperature is driving, and I'll get into why that is in a second. Now, in addition to temperature, we also looked at chlorophyll, or primary productivity. And you can see here, the one I like to highlight here is Biscayne Bay. And Biscayne Bay is going to have a peak, or this is going to be showing the effect of chlorophyll on their residency patterns. So anything above these dotted lines is going to be a positive effect, anything below those lines is going to be a negative effect. So you can see that there's sort of this peak in Biscayne Bay, and that actually correlates with when they're in Biscayne Bay the most, which is going to be towards the tail end of the wet season. I know they leave during the main part of the wet season, but when they come back, there's a lot of rain that's causing this runoff into the bay that's causing a lot of primary productivity. So it's cool to see that these things are overlaying with one another. So going into the connectivity part, this is called an abacus plot. And the way that you orient yourself with this is that these are each one of the different sharks that we have here, and these are its respective detections. And each color is going to represent a different region. So a couple that I like to highlight, the first one is going to be 9001-20773. I hope you remember that number because it's going to be important in the next slide, so make a mental note. You'll see that this shark has a lot of different colors. It's going to all these different places. There's a huge amount of connectivity. And you can see these two sharks down here. There's going to be a lot of connectivity patterns. So to orient yourselves, the red is going to be Biscayne Bay. You see that there's a lot of sharks that are hanging out in Biscayne Bay, but they go to these other regions in between, and they come back to Biscayne Bay, which is the most incredible part. They can go all the way up to Maryland, and they'll come back to Biscayne Bay, spend some time there. They'll go to the Florida Gulf Coast, spend some time there, come back to Biscayne Bay, and spend a lot of time there. So, do bolts return to the same area? This is 9001-20773. My favorite bull shark is a female 2.5 meter bull shark, at least at the time of tagging, which was back in 2016. So you can imagine how big she might be now, because I'm still getting detections from her. It's incredible. And this shark, as you can see, this is my favorite part of the presentation, tagged in Biscayne Bay, goes all the way up to Ocean City, Maryland, comes back all the way down, goes to Alabama, and kind of does that pattern several times. And I made this GIF back in 2019, 2019, and I have a lot more detections of this shark coming back to Biscayne Bay. Recently, this shark came back and spent 3 months in Biscayne Bay, and then I think I got detections recently of it in the Florida Gulf Coast. So it's really incredible to see, but showing that Biscayne Bay is a very important area for this particular bull shark. And it's actually not just 9001-20773, it's these other two as well. You can see that both these sharks tagged in Biscayne Bay are just going back and forth, especially between the area around Tampa to Miami. And the cool part is they're kind of doing it at the same time. So if you follow both the red and the green dots, a little more you can sort of tell that they're kind of going there back and forth. And they're both mature females as well. So one of the things with our bull sharks, we tagged a lot of them, right? But we tagged a lot of females, so we're kind of biased in that regard. So what we wanted to do is we wanted to take all of our catch data and see, all right, we see a lot of these females coming back to Biscayne Bay. Is that just because we tagged mostly females? Or is it because these large females are coming back for a reason, and it's mostly females that are coming back to this area? So all those drum lines that I showed you earlier, we took those data and we standardized them, and we looked at the catch per unit effort. In our case, catch per unit effort is a way to standardize catch data, and the way that we calculated that was taking the number of sharks that we caught divided by the number of lines or drum lines that we set per month. So, and then another thing, 14 of the 16 sharks that we were tagging in this study returned to the Biscayne Bay after going to another region. And like I said, they're mostly females tracked, and we analyzed the catch data. And from the dry season to the wet season, we found that there was a significant increase. There was a 96% of increase of mature females coming back to Biscayne Bay, as opposed to males, which went down by 32%. So this is sort of reassuring what we saw in our tracking data. These females are coming back to Biscayne Bay. So the next part is, why Biscayne Bay? Why is this an important area? Well, we can see that some juveniles that are staying in the bay. We have one juvenile that spent its entire tracking period in Biscayne Bay and did not leave. Another thing that we saw is that subadults that may have matured over time, when we tagged them, they were subadults, but given a couple of years, I believe they grow at a rate around 5 centimeters per year. By the time that happened, or a couple of years later after they were tagged, they actually stayed in Biscayne Bay and then left and went to the North Gulf, and these were all females as well. So you can see here, these three sharks, there were these three sharks here, tagged in Biscayne Bay, hung out a couple of years later, then went to the Florida Gulf Coast and then came back. And you can see these with these two sharks right here, hung out in the Florida Keys and Biscayne Bay, and then suddenly went to Florida Gulf Coast, North Gulf. And then this one in particular, this one was a subadult when we tagged it, but it was very close to the length at maturity. So right after we tagged it, it immediately went to the Gulf Coast, came back, Gulf Coast, came back. And then in addition to that, we have these mature females that are returning back each season. And you can see these ones circled here. They're going to Biscayne Bay, going into another region, coming back to Biscayne Bay, and they're just doing these cyclical patterns. So it's really incredible to see that these sharks are coming back to the same exact area year after year. So given that, we have some questions for future research, which we're hoping to do in our lab. And one of those is, what is going on in Biscayne Bay? Is it a potential nursery habitat for juveniles? Are these sharks giving birth to pups and they're hanging out here? My advisor was out one day and claimed that he saw a juvenile nurse shark in the canal in Miami. So I think going off of that, we might need to go into those canalways and start tagging juvenile bull sharks and seeing if it's really true, if these females are coming here to give birth, because other than that, nobody's ever looked into that before. And are there populations that are separate from one another? A study that came out earlier this year actually showed that bull sharks were going from Mobile, Alabama, and they were coming down to the Florida Keys and going back. They weren't going farther than the Florida Keys. They weren't getting detected in Biscayne Bay. They weren't getting detected in the Atlantic coast, which seems that there might be a separation. There might be different populations that are going on here. In addition to that, the Indian River Lagoon that's right here, that is a known spot for juvenile bull sharks where they're actually giving birth. And these sharks tend to just go north and come back down. They do not tend, I mean, obviously you'll have individual variability. You'll have some sharks that actually do come back around the Florida Gulf Coast, but most of them are going up and down the Atlantic coast, which seems to mean that there are some subpopulations that are going on. So I think one of the future directions of our lab is to do more genetic work. Look at these sharks that are tagged in Biscayne Bay, look at their genetic composition, and compare those to sharks that are tagged up near Mobile, Alabama, or in the Indian River Lagoon. And as I was saying earlier, is Biscayne Bay a possible pupping ground? Because we do have known pupping grounds in Florida, and a lot of these regions are very similar to Biscayne Bay. So that was the bull shark study. Hope you enjoyed it. Now I'm just going to go into some other projects that we've been doing, and one of them is hurricane sharks, Sharknado, hurricane a shark. I don't know, whatever you want to say. So a paper that we came out earlier this year looked at just that. We looked at tiger sharks that were in Bimini, Bahamas. We looked at what their patterns were when Hurricane Matthew, which was a Category 4 hurricane that directly hit Bimini, and we wanted to see what was happening. And we found that tiger sharks were very robust. I believe Tadzio was talking about that yesterday. Tiger sharks don't really mind. They just stayed. They didn't really do much. And you can see that here. You can see these detections are within the area, and they stay here right up until the hurricane, and they're there like pretty much right afterwards. And we also looked at that in Biscayne Bay when Hurricane Irma came through. And you can see here that, especially for bull sharks, you can see that they stop their detections and they don't come back till later. And you can see with great hammerheads, they stopped right before the hurricane and they came back right after. And then nurse sharks, they really don't care. They just stayed. They're like, I'm just gonna hunker down and it's gonna be okay. But one of the interesting things is a lot of these sharks came back right after the hurricane. And one of the reasons that is because the hurricane churned up a lot of fish, killed a lot of fish, and then the sharks just went on a feeding frenzy, which is really cool to see in these data. And the other research project, this is my master's thesis that just got published recently, so I'm glad to have that, burden off my chest, and I can actually talk to a group of people about it. But I looked at the relationship between boat activity and the urbanized coastal waterway, so we wanted to see how sharks were responding to boat traffic. And we did that two ways. To get boat traffic patterns, we used aerial surveys with another researcher, Jerry Alt at University of Miami, and we tried to get these, or we analyzed these boat traffic patterns, and we came up with these density charts. So if you want to orient yourselves, A and B are going to be on the weekdays, and then C and D are going to be on the weekend holidays. So you can imagine Miami is a very recreational boating central place, and everybody loves to go out on the weekend and holidays. And then we also used these underwater hydrophones. So if you can see here, C is going to be our acoustic receiver that's tracking the sharks, and then A is going to be the hydrophone, and that's going to be just listening for the soundscape of the underwater environment. So whenever a boat passes through, we can capture that on our hydrophone, and we can mark that a boat was present at this time, just like we would with our sharks, and we compared those two things. Now, from the aerial survey study, when we related that to the residency patterns at each one of these acoustic stations, we actually found that there was really no detectable pattern. However, when we looked at the hydrophone data compared to our shark residency patterns, we did see a slight negative relation was significant between nurse sharks and hourly boat passages. So the amount of detections per hour compared to the hourly boat passages, nurse sharks actually decrease their residency when there are a lot more boats, which was extremely interesting to see, and I'll explain why that might be in a second. When it came to hammerheads and bull sharks, one, we really didn't have that much data, nor did we find some detectable pattern between those two. Now, there's a lot of limitations to this study. I know that if you're driving around on a boat and you run into a shark, the shark's going to dart the other way. So the way that you think about this is going to be a little bit over a larger temporal scale. So with more boat traffic, are they leaving these areas during the weekdays and the weekend holiday, or during the weekend holidays? But one of the reasons that we do see these patterns, like we don't see a pattern between boats and hammerheads and bull sharks, and we do see a pattern between nurse sharks and boats, is because of their hearing ability. Now, when it comes to hearing, teleost fish, or bony fish, things that aren't like fish that aren't sharks, a lot of them have these swim bladders, and they can detect both parts of what we know as sound. And those two parts are going to be particle motion, and that's going to be the frequency. That's going to be the vibration that you feel from a sound. And they can also detect sound pressure, how loud something is going to be. And the reason they can do that is because they have a swim bladder. We can hear like how loud something is because we're in air, which is a compressible medium. Water is not a compressible medium unless you have a swim bladder that can be compressed. So a lot of fish that have a swim bladder that is connected to their inner ear can hear how loud something is. And there's a lot of studies out there that show that boat traffic does hinder these fish's ability to either hunt or be hunted or to mate even. So we wanted to look at this with sharks as well, but sharks, elasmobranchs, they can only detect particle motion. They do not have a swim bladder. And so they can't detect how loud something is. So when we look at it, and when we're trying to figure out whether or not they're actually being deterred by boats, we have to only look at the frequencies. So there haven't been any studies on bull sharks and their hearing abilities, but there has been a study on the Atlantic sharp-nosed shark, which is a cockerinid species. And in shark language, coccyrinid means a sharky-looking shark. So think of your white sharks, your bull sharks, your black tips, your black tip reef sharks. And with these sharks, they're they're as close as we can get to bull sharks. They're really hindered by 20 hertz sounds or frequencies. And when we look at an actual spectrogram, which is going to show how loud something is, so this is going to be a boat engine, and each line's going to be representing a different RPM that the engine is revving at. And you can see that the most intense sounds are coming at between 300 and 600 hertz here. So for species like bull sharks or like this Atlantic sharp-nosed shark, that's not really going to overlap. So that might be a reason why we're not seeing much of a pattern in bull sharks and boat activity. However, with nurse sharks, they were the most sensitive at 300 to 600 hertz. Which means that that's probably why we saw a negative trend in nurse shark detections and boat activity. And also another thing is habituation. There have been a lot of studies that looked at what happens when we expose sharks to prolonged sounds. And what happened was there are these two studies, Meyerberg and Richard in 1969 and Nelson et al. In 1969. And they exposed these sharks to either prolonged sounds or low frequency pulse sounds. And at first the sharks would come in and be attracted to it, and then they would become used to it. They'd become habituated to it. They really didn't care about it. And we actually see that in some teleost fish species as well. When this fish was exposed to boat engine noise over time, it just got used to it. So that might be a reason why we're seeing this pattern in bull sharks and hammerheads. Also, if you think about it, Miami's been a very recreational boat traffic center of the United States for decades and decades. So it just might be that these sharks are exposed to boats all the time and they're just used to it. And they've adapted in this environment, which is also pretty incredible. But that is all I have for you tonight. I really want to thank See and Learn Saba for everything. I mean, this is an incredible experience. And the island, thank you all. And with that, I think I was on time. Is that good? All right. Any questions? Yes.
I have two.
Okay.
Number one, why were so many female sharks tank compared to the males? And number two, your favorite shark that went up north a couple of times, were there differences in the water temperature or anything that made her not go up to the north and come back down?
All right. So the first part of that question was why are we tagging more females than males? I think a lot of it has to do with the time of year that we're tagging. We do tend to tag more in those in the dry season, because a lot of our tagging projects are school oriented. So if you think about the school year, that's going to happen in the dry season. So a lot of our tagging efforts could be during that time. I think that's my best explanation for that. And then your other question was the one shark that went all the way up north, and right. You know, it could be a variety of things. I think one of the limitations with acoustic telemetry is that, you know, these tagged sharks need to be within a certain distance of those receiver stations. That shark could have very well gone up there, and we just wouldn't know. It could also, you know, it's also opportunistic. Maybe there's something that we don't know about their actual yearly patterns. Maybe it's not so much of an every year they go up there and come back. Maybe they stay in Biscayne Bay for other reasons. Maybe it's to actually give birth and they stay during that time. That's, you know, highly speculative, but that could be a reason why. This question back.
Well, I have a question about the same shark, because you could see that on its way up north, it followed the coastline, but on the way back down, it was a straight line, so probably because there were no receivers in that area.
Mm-hmm.
So do you know why it followed the coastline to go north and then the deeper ocean to go south?
That particular... Oh, yeah. She was wanting to know, like, when that shark was coming back down, it hugged the coast, or when it was going up, it hugged the coast, and when it came down, it was a little more offshore. That's also just the GIF. It's really it's like those are just going from point to point of where the receiver stations are. So if it's not detected, like it could have very well taken that same path, but it's only detected in point A and then just makes it to point B. So it just looks like it does that. Bull sharks are generally going to hug the coast more. I don't think they go deeper than 200 meters. So they pretty much stay on that shelf the entire time. Yes.
One of the observations you were mentioning was the sawfish.
Mm-hmm.
Isn't that primarily a freshwater fish?
No, it's saltwater.
Oh, is it?
Yeah.
I think it was something else.
I think it is a freshwater species. Yeah. Yeah. No, these are mainly, I think those sawfish, I think their movement patterns is they tag them on the Gulf Coast of Florida, and they actually go just up and down the peninsula like this. Yeah. Yes.
How many islands in the Caribbean have receivers in place?
I actually don't know about that. I was talking to Tadzu about that last night. The question was what other Caribbean, or how many other Caribbean islands have the acoustic receivers set up. I do know that somebody is trying to make one of those acoustic networks down here, specifically for this region. I don't know where that is. I know that Ocean Tracking Network, the big one that I was talking about, they have a great effort at trying to get people to join these cooperative telemetry networks. I think there's a lot of researchers doing that stuff down here, but talking to Tadzio yesterday, it seems like there's not a lot of conversations between those entities going on, which is unfortunate because you really want to know what's going on.
What depth are the receivers, and if the bottom is lower, do you tether them or something?
So the question was, what depth are those receivers at, and if they're deeper, do you tether them? There's a wide array of ways to do it. Our receivers in Biscayne Bay, they're mostly around 10 feet. Some of them are like 3 feet, and deepest is 20 or 30. When you go to different regions, they can be a lot deeper. They can be 100 meters of water. Another grad student of mine was working, in my lab, was working in South Africa, and those depths were like 100 to 200 feet. And the way that they did that is they literally took pieces of railroad track and they tied a line to it. And the line would go up and it'd be suspended by a little float, maybe about 10 feet off the, substrate. And, they just tether the receiver there. Some other options is if you're working in those deeper waters is they have these sort of acoustic release systems where they're on this little platform, and then you put like a microphone or a speaker in the water and you play a certain frequency and it causes it to release and have the receiver come all the way up and floats up to the top. You can imagine how stressful it is when you click that button and nothing comes up, but
So, depending on the depth of the receiver, can it detect the animal if it's not at 10 feet and it's at 100 feet?
It should theoretically, yes.
You can get into like the whole physics of it, of underwater sound, and how like the the isotherm layers or how it affects it, because different temperatures can cause sounds to travel different distances and attenuate or last longer or last farther. Theoretically, I mean, it could. I think there's a lot of different environmental factors that play into that. And I also think, the deeper you go, I think the farther they can detect. Or actually, no, it's sort of in the middle of the water column, but like I said, there's a lot of different factors that go into the detection distance. And that's something that we have to do with our array. We have to go out there and we put in these little dummy tags and we leave them overnight at different distances so that we can get sort of like at what distance do I get 50% detectability? So I know all these transmissions went out, but I only detected 50% of them. What was that distance? And like for an example, in Biscayne Bay, that was like about 250 meters is the 50%. So 250 meters, we get about 50% of the detections that we should theoretically get. Yeah.
So between your and Tazio's presentation, it seems that you're mainly tagging females. And I'm just curious in terms of why. Like, are you actively trying to tag only females because of their reproductive capability and like what they would do in that stance, or are males just like that much harder to tag or that much rarer? And why?
Isn't the question why are they getting caught more?
Why are females getting caught more?
Oh, that's a very nice question. So I think, with what Tazio was talking about, him specifically is they're targeting females, so they probably catch males as well. But the work that they're doing, the questions they're trying to answer are female-centric because they want to know, like if they're pregnant, where are they going afterwards? Yeah, with the ultrasounds. For us in particular, those bull sharks were tagged a year or two before I actually joined the lab, and it was for a different project. And it was more like, we catch a shark, we're going to tag it. And it'd just be more opportunistic, and it just happened to be that way. Which is, it's not the best way to go about it, in my opinion, but sometimes in that kind of field, you got to take what you can get. Yeah.
On the same event, it's exactly the same things. Whatever we caught, we tagged.
Yeah.
And we just happened to catch more female than male.
Yeah. I couldn't exactly tell you why that is. I think, specifically in Biscayne Bay, I think it's more because that Biscayne Bay might be an important ground for those females. Save it back, I don't really know, but I think that I'm getting cut off. If you have any questions, I'm going to grab a drink so I can cool off for a second. And then you can ask me whatever you want. If you get a couple drinks in me, you'll get a more flavorful answer, maybe. I don't know.
Alrighty, guys, that concludes our See and Learn for the night. One more big round of applause for Mitch out here. Awesome. Now, a few thank yous that we do want to do. A few thank yous is going to be to Long Haul for letting us use their room again, but especially, big round of applause. But especially to Shea Booba. They did all the drinks tonight, and they're doing food if you got reservations, all right? So Mitch is going to be over there. If you guys want to ask him questions to your heart's content, he will stay up all night answering your questions. That's what he told me, okay? So just keep buying him drinks, all right? And other than that, thank you guys, and we will see you next time.
The presenter should not buy a drink.